All right, this is very exciting. It's been a while since the Autogen team have published new papers on new features, and they just recently shipped a new feature which is called Captain Agent. By the way, the name of the project has changed to AG2. So if you guys are not following the new GitHub repository, make sure to start it. I will obviously share a link in the description of the video. Anyway, Captain Agent is pretty powerful. I haven't tested it on my own, but I've read the research paper and I will share it with you in a moment. And I've also gone through a few of the examples that are being shared in the repo, and obviously we will cover them. And in upcoming videos, I'm going to start messing around with the Captain Agent. Let's dive into what is exactly Captain Agent. We will start by reading the blog post which was published by the AG2 team. Okay, so basically, the challenge is when you build an agentic framework, you don't know exactly which agents should you build. So in some instances, let's say you don't have any financial constraints or compute constraints or any constraints, so your obvious reaction would be, okay, why don't I just build a huge amounts of agents specific for every use case? But obviously this isn't scalable, and we do have constraints, and in many instances, in many subtasks, we won't use all the agents that we've built. So this makes it kind of irrelevant to just build a ton of agents. On the other hand, if we don't build enough agents for the specific use case, sometimes the results that we will get won't be as good as if we had more agents. So what they propose here is basically leveraging the auto build system, which is a system that they already introduced, I think like 6 months ago. But this is a kind of refreshing approach and even better. And this is called the Captain Agent. Basically, dynamically assembling a group of agents capable of effectively solving the problem in complex challenges. So Captain Agent is an intelligent agent that can autonomously assemble a team of agents tailored to meet diverse and complex task requirements. And it basically iterates over the following 2 steps until the problem is successfully solved. And I will show you examples in a moment. So first of all, Captain Agent breaks down the task. He recommends several roles needed for each subtask. And then it dynamically creates a team of agents based on the task. Each agent in the team is either generated from scratch or retrieved and selected from an agent library. If you have like a pool or a library of agents, it can be retrieved from the library. And each of them will be equipped with predefined tools retrieved from the tool library if provided. And we will cover a few examples later as well. Now, for each subtask, the corresponding team of agents will jointly solve it. Once it's done, a summarization and reflection step will be triggered to generate the report based on the multi-agent conversation history. And based on the report, Captain Agent will decide whether to adjust the subtask and corresponding team, like do another iteration, or terminate and output the results, meaning he likes the results and he wants to move forward. And this is excellent because in many instances in the past, when I use agentic frameworks, and probably when you use it as well, you encounter hallucinations or like endless loops of just going back and forth between agents. So this step of reflecting on the conversation is very powerful, and I will show you later on in an example how it is being used and how basically using this step of reflection and verification is very powerful, because then it creates another iteration that actually verifies the output. Now, these are examples of how you can build this, and basically you can just come to the repository and see all the examples which we will cover in a moment. But before we dive into the examples, let me show you a brief overview of the paper. Obviously, if you're interested, you can dive into the paper and read exactly how they did the different, like what were the methods of conducting the experiment. All in all, they saw a 21% improvement in average accuracy in different verticals, so programming challenges, math challenges, scientific challenges, chemistry challenges, physics challenges, etc. Let me just show you the tables. This is basically the flow, how it works, but you will understand better when we cover the example. Let me see, I wanted to show you a few of the tables. So these are the 6 types of scenarios that they tested. And these were the results that it yielded. And they compared it to different agentic frameworks and flows. And also something that was interesting, they also did a comparison if the Captain agent can yield better results with inferior models, and it did seem to yield very good results with even inferior models. Let's see, what else did I want to show you? Okay, basically the conclusion. So I'm going to read as if I'm part of the team, not yet. We introduced a new paradigm for multi-agent team building, adaptive build. This new paradigm helps ensure diversity, prevent limited knowledge extraction, and reduce stereotypical outputs. The new paradigm, executed by our proposed agent, the Captain agent, manages agent teams for problem-solving steps using adaptive multi-agent team building and nested group conversation and reflection. I know it might sound like just a bunch of buzzwords if you don't know all the definitions, but again, in the examples you will understand better. Experimental results across 6 real-world scenarios demonstrate Captain agent's efficiency in various tasks without prompt engineering, achieving superior results compared to existing methods. Let's move on. Okay, so here are a few examples, just so you'll understand the flow. So very basic, the Captain agent is being required to find a recent paper about large language models on arXiv and find its potential applications in software. So Captain user proxy to Captain agent gives him the task. Then we have the expert summoner, which is basically an agent, you can say, that is being involved in the whole conversation. So as you can see here, find a recent paper about large language models on arXiv and find its potential application in software. Now the Captain agent says, to find a recent paper about LLMs on arXiv and explore its potential applications in software, I will follow these steps. So search for a recent paper, then analyze the paper, then summarize the finding. Then it says, let's start by searching for a recent paper on arXiv related to large language models. I currently don't have direct access to external databases like arXiv to search for papers. However, I can guide you on how to find a recent paper about LLMs on arXiv and analyze its potential application in software. These are the steps, and these are potential application in software. If you find a specific paper and need help analyzing it, feel free to share the details and I can assist you further. Then we have the expert summarizer. I'm a proxy and I can only execute your tool or end the conversation. If you think the problem is solved, please reply with the word terminate. So then it says, it suggests calling basically the tool, which is seek experts help. And this means it's going to build a tool of agents. So building task, a researcher with expertise in large language models and their application in software, a software engineer with experience in implementing AI models in software application, a reviewer to verify the analysis and ensure the accuracy of the findings. So basically, it's going to build these 3 agents: the researcher, the reviewer, and the software engineer. Then it tells the task description, and now we can see the auto building all the agents, the researcher, the software engineer, and the reviewer. Then it starts executing the task. This is the task description, the plan for solving the task, the output format, and the constraints and conditions for completion. Then it is generating the agents. Then it is generating the system message for each agent, and then it is generating the description. For those of you who don't know what is the difference between the system message and the description, you can view the system message is kind of the longer description that is given to each agent on how he is supposed to operate, while the description is usually like a one-liner, and this is the description that other agents can see in the conversation, and this is how they know how to call specific agent in the conversation. So description, one line, is kind of like an external explanation of the agent ability, and the system message is an internal explanation of the agent's ability. It's his operating system. So yeah, if you want to kind of memorize this, just something that I completely made up now. So system message contains the word system, and it's the operating system of the agent, and the description is the external description, how you would describe an agent to someone else in the conversation. Then it creates the agents, and basically it starts with the task. We have the computer terminal, which basically can execute code. In every iteration we see it, and basically it checks whether or not there is a code in the last message. If there is a code in the last message, it's going to execute the code. So since there is no code in the last message, the group chat manager should let other participants to continue the conversation. So we have the AI implementation expert. It tells the chat manager, let me start by finding a recent paper on archive related to LLMs. I'll search for a paper that could have potential applications in software and then analyze it accordingly. I'll proceed by drafting a search strategy for archive. I don't know if I'm pronouncing this correctly, but let's assume that I am. To locate a paper, let's begin. So access the archive website, use keywords such as LLM, software applications to filter recent publications, and then identify a paper that seems promising in terms of application in software. Then the computer terminal sees there is no code, moving on. So software application expert, it seems we need an example of a search that could be used on archive to find such a paper. Here's a possible approach using archive's search functionality. So basically, he writes a Python code, import archive, search for recent papers on large language models, print the title and authors of the found papers. Let's run the script on the computer terminal. Now the computer terminal, in this case, he does have code to execute. He executes the code. These are the titles, these are the authors, publication date, and the summary. Then we have the analysis review expert. He basically reads the output from the code, and he says, I have identified several recent papers related to LLMs based on their site titles and summaries. One of the papers that stands out for its potential application in software is, and then basically it shares this paper. Then it says, this analysis highlights the potential impact of the spec tool benchmark on enhancing software applications, blah, 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 moving on. Then it says the accuracy verification expert says the chosen paper seems highly relevant to the task of the integrating large language models into software application, given its focus on error evaluation and tool use tasks. To ensure accuracy in our findings, first, let's consider the implications of potential inaccuracies in tool use LLMs and verify that spec tool is indeed addressing these concerns effectively through comprehensive benchmarks rather than just providing a success rate. Test case proposal, develop a hypothetical scenario where a software application employing LLM utilizes spec tool to evaluate and mitigate errors. And if these steps confirm the potential benefits and application of spec tool, we can consider the task complete. Shall we proceed with with this verification process to ensure thoroughness? Again, computer terminal sees there is no code. Then the accuracy verification expert says, let's conduct a verification of the effectiveness of the benchmark. Moving on. Then we have again the export summoner, which basically says response from seek agent help. The task is to find recent paper about large language models. Let's move on. Results. So this is basically like the summary so far of the conversation. The group chat identified the paper titled Spec Tools. Summary of potential applications. Here's the summary of potential applications. The reason for the results. The chosen paper stands out for its focus on evaluating errors in LLMs, which is a critical aspect of integrating these models into software applications. The paper benchmarks and methodologies provide valuable insights that can benefit software developers and researchers in refining AI systems. Errors or issues in the conversation. There appears to be no significant errors or issues in the conversation. Basically, it reads the whole conversation and sees if there are any hallucinations or any endless loops. And then it says whether or not we need to double check. In this case, it says no, but later on there are instances in which it says yes, and these are very important and interesting. This is like kind of like the bottom line. In a moment, I will jump to another example. I will make it shorter, and I just want to show you this iteration of double checking. But the bottom line, basically what the captain agent said, the initial task was to find a recent paper about large language models on archive and analyze its potential applications in software. The experts plan to search for a recent paper on archive related to large language models, analyze the paper to understand its content with a focus on potential applications in software, and summarize these applications. The group identified the paper titled Spec Tools, blah, 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 as relevant. The paper evaluates large language models and used in compound AI systems, focusing on error identification and tool use task. Spec Tool, the benchmark discussed, aids in understanding. Never mind, let's move on. And yeah, the experts concluded that the paper was relevant and provided valuable insights for software developers and researchers in refining AI systems. In my opinion, this is pretty amazing. We just gave it like one line. The captain agent built the whole team. They did the research on their own, created the tools, used the tools, made sure there were no errors, no hallucinations, and gave us the bottom line. This is crazy. I already want to start building my own workflows. Let me just show you. I mean, they have a few more examples here. All the examples are important because they show different aspects of this solution, using tools, not using tools, but I don't want to make this video any longer. So let me just show you this part in which they do need to double check again. So here, the export summoner basically says errors or issues in the conversation. An initial error in the Python script due to unsupported keyword argument in the archive API script was resolved by removing it. Then there was a suggestion to verify the categorization by reviewing the abstracts to ensure they are correctly classified and to check the accuracy of URLs, authors, and publication dates. So basically, these are things that the summoner, or let's call him summarizer, saw during the conversation. So based on this, he concludes that we need to double check. And then he says, what else would he like to see in order to double check? So additional information, verification script provided for rechecking paper detail using the URLs and archive ID. Example markdown table with categorized papers is included in the conversation, but each paper abstract verification and realignment of the table structure for accuracy are advised. So basically now the captain agent is going to build agents to verify the errors. So as you can see here, building task, it builds an expert in data collection from academic sources, an expert in categorizing and organizing academic papers into different domains. And this is exactly based on the errors that came up during the conversation. A checker who verifies the accuracy and completeness of the collected data and categorization. And then they just do this whole thing. They do like all the verifications and check accuracy and do the data collection. Let's move on. The computer terminal executes the code. Again, they had an error over here. Let's move on. I just want to show you like how they take the nested conversation of the error validation and move it back to the conversation. Okay, so response from calling tool. Okay, the task involves collecting, categorizing, and verifying paper on LLM application from archive published in the last week. The aim is to ensure accurate details and correct categorization in a markdown table. The explored solution should provide insights on future research directions based on the collected data. Results. The conversation led to the successful execution of a Python code to fetch recent LLM-related paper from archive. The program successfully retrieved a list of papers, including their details such as titles, authors, publication dates, abstract, and URLs. Let me see. I think this is another step. There were initial errors related to this. We already saw this. Okay, moving on. Let me see. Okay, so let's see what's happening. Okay, the task of collecting and categorizing and verifying. I'm a bit lost here. Let's see. We need to double check. The discussion includes Python check. Okay, the task of collecting, categorizing, and verifying papers on LLM applications from archive has been successfully completed. The experts have resolved initial issues with the Python script and ensured accurate data collection and categorization. Here's the summary of the results and future research directions. Let's see. Okay, and then the captain agent gives us the bottom line. Let's see if it includes the verification step in the bottom line. So the initial task was to find papers on LLM applications from archive published in the last week. Create a markdown table categorizing these papers into different domains and identify future research directions based on the collected data. The expert planned to collect recent papers, categorize them into domains like NLP, computer vision, human-computer interaction, benchmarking and evaluation, etc. They also aim to analyze the data to suggest future research directions. The experts executed a Python script to collect papers from archive, but faced initial issues with the script due to deprecated methods and date and time comparison errors. These were resolved by updating the query parameters and methods. They successfully retrieved a list of papers with details such as titles, authors, publication dates, abstracts, and URLs. The experts verified the accuracy of the data and categorization, ensuring correct details and domain classification. Amazing. The results included a markdown table categorizing the paper and a summary of the future research directions, which highlighted trends in cross-domain applications, the need for benchmarking and evaluation, ethical and social implications, and efficiency and scalability improvements. The experts concluded with a comprehensive overview of the current state and potential advancement in LLM application. Again, another example, in this case, we also saw how the captain agent or the whole framework saw that something wasn't quite clear. There was an error during the conversation. So it built another team of agents to verify and make sure that the data is categorized correctly and classified correctly and is accurate. Now over here, there are a few more examples, but I won't go into them because I'm already, the video is already pretty long and I think we get the gist. But if you're interested, I highly recommend that you check the other examples as well, because each example is kind of different and gives you a better perspective about this amazing solution. In the upcoming days, I'm going to research this. I'm going to build marketing related flows. I already want to see how I can implement like prospecting research, lead research, and company research, workflows that are more relevant for marketing and business, not necessarily, I mean, you can consider also this workflow business related, but more marketing related. I guess that's it for today. I hope you enjoyed this video. Obviously, if you did, please make sure to subscribe, leave a comment below with your ideas, suggestions, or criticism. And until next time, keep on automating.